Hi, this video is taken for Open Hardware Contest IIT KHARAGPUR. This is Syed Aslam, Tamil Nadu. These are all the components that I am going to use for my project. And the title of my project is Cost Effective Vehicle Automation and Security using Renesas microcontroller. This is the brain of my project. This is the only ready-made component that I am going to use for my project. This is a Renesas R8C Tiny or Renesas R8C 25 processors development board, which I am going to use for my project. Basically, I am going to automate three things: headlamp, wiper motor, and CO protection. This is the wiper motor that I am going to automate, headlamp that I am going to automate. This box consists of the driver circuit and the power supply unit. This is the CO sensor, MQ7 sensor, which will detect the carbon monoxide gas. This is our basic IR sensor, which is used for the detection of rainfall. This is our basic LDR, which I am going to use it for the reduction of illuminescence in the environment. This is the buzzer that will give alarm whenever CO gas is detected. And this is the motor, which is basically a DC motor, which I am using as a prototype. Instead of a window motor, whenever the CO gas is detected, this motor will go down. I said that I am going to automate three things. One is headlamp control, another is wiper motor control, and another one is carbon monoxide protection. Does not all these things already exist? Yes, they exist. But where? They exist in the cars that can only be bought by royal peoples. Nowadays, even the cars which comes around 8 lakhs also include some of these features, only one or two, not all these things. So the purpose of my project is, as I said, cost effectiveness. I am going to reduce the cost so that it can even be implemented in Tata's Nano or Maruti 800, which can be bought by even a middle class person, so that the technological growth benefit can be even given to the middle class person. So now how I am going to automate all these things? So first I start with the headlamp. What I am going to do here is, in the headlamp, depending upon the environment's illuminescence or light, environment's light, the headlamp's light need to be increased or decreased. Just not switching on and off, it is between that. So as we know that to make this thing work perfectly, that is between on and off, there should be a value. To get this, we have to go for a logic called as fuzzy logic, which is just not 0 and 1, it's between zeros and ones. So I am going to implement fuzzy logic. To implement fuzzy logic, I have a tool called PWM, which is already built in my ADs, in my controller. So with the help of PWM, I am going to vary the duty cycle, and depends upon that my lights illuminescence will vary. For example, let us consider 70% light in the environment. So that 70% will be taken as the off time. The light in the environment will be taken as off time. So when 70% is off time, 30% will be the on time. So in a second, this 70 cycles and 30 cycles will happen more than 1000 times. So my light's brightness will be reduced. If 70% is the darkness and 30 is the brightness, 30 will be taken as the on time and 70 will be taken as the off time. So the light's brightness will be high. So if there is 100% light, the lamp will be completely off. If there is 100% dark, the lamp will be completely on, giving the full brightness. So this is how I am going to automate my headlamp. When I say that I am going to automate, give security for carbon monoxide gas. Why security against carbon monoxide? What is the necessity of this? Yes, it is really needed. Since we have already seen more news coming in the newspapers about the deaths in the cars due to carbon monoxide leakages. And even in US alone, per year there are more than 200 people dies due to carbon monoxide leakage in the gas, in the cars. So to automate or to identify the carbon monoxide, I am going to use a sensor called as MQ7 sensor. Since I cannot give the demo with carbon monoxide, I have replaced the MQ7 with MQ2, which will perform the same function except that it detects smoke. So I am going to use smoke to show you a demo. Once the CO gas is detected, the windows mirror will go down and the alarm will be given, and also exhaust fan will be switched on, so that the gas remains in the car can be pulled out, and even the engine will be switched off. This is how carbon monoxide protection is going to be applied. And when I say that I am going to automate the wiper motor, I have to detect the rainfall. To detect the rainfall, I am using our basic IR sensor. This is the prototype which I have developed to show the wiper shield. So this is IR sensor. Whenever the rain falls, it detects and the wiper motor will be switched on. All the sensors are interfaced with the ADC of my controller. Now let us see the demo. See this, friends, this is LDR. So whenever the light is not given, see the brightness is full. So this is the PWM concept. Now let us see how the CO protection is given. I am going to give smoke to this MQ2 sensor. It's not MQ7. Whenever the smoke is given detected, my motor goes on, so that the window gets reduced and my buzzer starts giving alarm, so that the people inside the car get alerted. And as far as the rainfall is concerned, I have a bug here. This IR sensor is able to detect the rainfall, but at present I am unable. When I come for the final presentation, this bug will be removed. But now I am going to use my hand instead of rainfall to show how the wiper runs.